Hello everyone, and welcome to today's class. In this lesson, we're going to start from the very foundation of mechanics, something you experience every single day, whether you're walking, driving, throwing a ball, or watching the rain fall. All these everyday actions are governed by the laws of mechanics. But to study these actions scientifically, we must first learn how to measure them properly. That brings us to our topic: physical quantities. Now, what exactly is a physical quantity? A physical quantity is simply any property of a material or a system that we can measure and express using a number and a unit. For example, if I say, the length of the table is 1.5 meters. The 1.5 is the number, and meter is the unit. Both are important, because without the unit, that number means nothing. When describing any physical quantity, we must always specify the unit. In physics, we use the SI units, the International System of Units. This is because using one universal system avoids confusion. So whether the measurement is taken in Africa, Europe, Asia, or anywhere else, the meaning remains the same. Physical quantities are grouped into two major types: fundamental quantities and derived quantities. Let's begin with the fundamental ones. Fundamental quantities are the basic measurements in physics. We do not define them in terms of any other quantity. They stand on their own. According to the SI system, there are 7 fundamental quantities. Let's go through them one by one, slowly. Length, mass, time, electric current, temperature, amount of substance, and luminous intensity. These form the foundation for all other measurements in physics. Let us look at derived quantities. These are quantities that come from combining 2 or more fundamental quantities using physical laws. For example, speed is distance divided by time. Distance is a fundamental quantity measured in meters. Time is also fundamental, measured in seconds. So the unit of speed becomes meters per second. Here are some common derived quantities and their SI units. Let's go through them slowly so you understand each one clearly. Notice how each of these units comes from combining the fundamental ones. Let's take one example: acceleration. Acceleration is the rate of change of velocity with time. Velocity itself is meters per second. When we divide that by time again, we get meters per second squared. That's how the unit m/s squared is formed. Every derived quantity follows this same pattern. Let's quickly recap what we've learned. A physical quantity has 2 parts, a number and a unit. Units must be in the SI system for clarity and consistency. There are 7 fundamental quantities which cannot be broken down further. Every other quantity, velocity, force, energy, pressure, is derived from these fundamental ones. Thank you for joining today's lesson. Take your time to review each quantity, understand the units, and practice converting between them. In our next class, we will build on this foundation and explore even more interesting concepts in mechanics. See you in the next lesson.